Hello everyone, this is Sri Katkam from Mari Lakshman Reddy Institute of Technology and Management, Hyderabad. This is my immersive internship IoT based home automation solution. The topics covered in the internships are C programming, C++ programming, embedded system, IoT, Internet of Things, Arduino UNO, Pixel Lab, project objectives and requirements, simulations, conclusion. First of all, C programming. C programming is a full, powerful general purpose programming language. It was designed to be compiled to provide low level access to memory and, and language constructs that map efficiently to machine instructions, all with minimal runtime support. Topics covered in C programming: keywords, data types, operators, arrays, pointers, functions, etc. C++ programming. C++ is a general purpose object oriented programming language. It is viewed by many as the best language for creating large scale applications. Now, the embedded system. Embedded C is an microcontroller based programming language. In simple words, embedded C is a set of language extension for the C programming language. IoT, Internet of Things. IoT is describes physical objects or group of such objects with sensor processing ability, software and other technologies. Why home automata? People usually are outside the home for many reasons like traveling and they want to control some device far from home. So those devices are want to fill the water tank and want to turn off the lights in garden, get feedback about the temperature. Arduino UNO. Arduino UNO is based on an 80 mega 328p microcontroller. It is easy to control compared to other boards. This is how Arduino UNO looks like. PiximLab. PiximLab is a real-time emulator of development boards with integrated MPLAB AVR GDB debugger. This is how PiximLab looks like. Project objectives and requirements. There are two requirements, hardware and software requirements. In hardware requirements, we cover these topics, and software requirements, we cover these topics. Garden light controller. During the day, the outdoor light is maximum, so the LER sensor detects the light and light is turned off. During the night, the outdoor light is very low, so the LER sensor detects the light and the light is turned on. LER sensor. This is how LER sensor looks like. Temperature sensor. Temperature is recorded by LM35 sensor, which is analog value, so it is then converted into binary terms and later actual temperature is calculated using the obtained value of the voltage. This is how temperature sensor looks like. Heater and cooler. Heater, it controls the temperature can be regulated using the heater and the cooler. This this is how cooler looks like. This is a relay and this is how heat and cooler looks like. Temperature control system architecture looks like. Here the control should be done according to the architecture. Water control. The steps consist of two valves, inlet and outlets. In inlet is used for controlling the inflow of water into the tank and outlet valve to eject the water. The tank refills itself when the outflow exceeds the threshold or the minimum value. The serial remote tank is a tank simulator controlled by the serial communication protocol. The tank has several sensors and actuators that can be made and controlled using the protocol. This is this is the program for LED. This is the output for LED. When the light is more light is emitted on the LED, so the light blinks very less. When the less light is emitted on the LED, so the light blinks more brightness. This is how CLCD looks like. Code for the CLCD. This is how CLCD output looks like. This is the CLCD frame. ADC. This is code for the ADC, and this is how outputs looks like. This is the cooler, and this is a CLCD flame. LED dimming. As the light more emitted on the LED, so the brightness of the LED will be decreases. As the LED light is increasing the light, so the light will be decreased. Analog write. This is how codes looks like. This is how its output. This is the LDR transmissions. Serial tank. Serial tank starts filling from 2000 level until it reaches 3000. Then the outlet inlet valve will be turned off and outlet valve will be turned on, so the water will be continuously decreased. This is a blink looks like. This is how blink like home automatons looks like in the mobile. When we turn on it, it shows these many readings in it. Simulation, the final conclusion of the project. This project provides a solution of monitoring and controlling home application and certain device remotely. CLCD acts like as a dashboard user for displaying the events. Widgets from Blink IoT app. The button widgets are used to control heater, cooler and inlet valve, outlet valve. Thank you.